Good morning, everyone. Today we are going to continue with the unit number 3, that is pillars of embedded IoT and physical devices. So in last session, we have seen about the horizontal application, vertical applications, the four pillars of IoT, that is machine to machine, RFID, SCADA, and that WSN. These are the four pillars of IoT. Now in today's session, we are going to continue with the DCM. Today's topic is DCM, that is device, connect, and manage. So first we will see the three-layer architecture for IoT. Here you can see the three-layer architecture for the IoT. Here you can see that there are three layers are there. First one is here you can see that sensor layer, network layer, and application layer. We are having three layers. So as we know that IoT based system has a long value chain that starts from the sensors, thing, communication network, and then platform like cloud and application. So that value chain categorizes service users, service providers, that are the your stakeholders. Okay, here you can see that we are having three layers, that is sensor layer, network layer, and application layer. So in the application layer, we are having the front end applications, or we are having the access to that application, that we are going to manage the application at the application layer. So here you can see that we are having the application development center. Okay, and this is a centralized control center is there, where we can implement, or we are going to develop that application. Then data storage and analysis center is there, or data processing center is there. So we are going to control the application through this one center. Okay, that is your centralized control center at the application layer. Okay, this is the application layer where we are having the front end application and application development center, and the data storage and here data storage and data analysis center. Then next layer is your network layer. So we have seen in the last two units that where the network layer consists of the wired or wireless communication network. Okay, so that we have seen that what is wired and wireless communication networks, and what are the protocols used at that network to connect with the application. Okay, so this is all about the network. That network may be a wireless network or wireless communication network. About the network layer, that network layer means here, see the connect network. Okay, and first one is your manage the application, and last layer is your sensor layer. That sensor layer consists of the field workers, industry plants, then the electricity transport and distribution. So at that, here you can see that sensor layer consists of the different kind of sensors like video sensors, then human monitoring. Then you can see that chemical, for the industrial plant, we are having the chemical or temperature, pressure embedded sensors are there. Then for electricity, we are having power and electricity sensor. Okay, so there are different kinds of sensors are there that are suitable with that particular application. Like for the field workers, we are having the uh, for the managing the workers location, we are having that electronic guard, or we are having that location. Okay, that we are having that video sensors are there, or human monitoring sensors are there. And for the industrial plants, we are having the embedded sensors, or we are having that temperature or the pressure sensor is there. And for the electricity transport, and for that monitoring, that we are having that electricity center. This is at the sensor layer. So this is the three-layer architecture of that IoT. So here that we have seen that all the IoT based application and all the services provided by that four layers, that is machine to machine, WS, that is wireless sensor network, RFID, and SCADA, follow this three-layer architecture. Okay, all four pillars follow this three-layer architecture. So that all the IoT system architecture works on the this layers, DNA layers. That is, we have seen that device, networks, and application. Okay, device, networks, and applications, or device, connect, and manage. Okay, so this all the IoT system architecture works on these layers. But some industries or some service providers divide these layers up to 9 layers. So some of the industries divides this layer into 9 layers as per their applications or their need. So these 9 layers can be, here you can see that the 9 layers. See this 9 layers architecture that several industry or several applications provider distribute this 3 layer architecture into the 9 layer architecture. So that 9 architecture consists of like devices, connectivity, data collection, communication, device management, data rules, administration, application, and integration. Okay. Yeah. Okay. So these are the 9 layers of from these 3 layers. So that several industries distributed that 3 layers into this 9 layers. Okay. So this 9 layers consist of like for the in case of we are going to consider as a DCM or the DNA, that is device, connect or manage, and device, networks and applications. If we are going to consider these layers, okay. So these 9 layers here you can see this data management, then server side or middleware platform and vertical application consist of, or this management of this data is at the application or application layer. Okay. And this core communication networks like communication, then telecom services, pervasive services are there, pervasive networks are there. These are at the network layer. And the sensors and actuators like we can see the smart objects or the local sensors in the networks are at the device layer, or what we can say that at the sensor layer. Okay. So these are the 9 layers. Then the next point is the, here you can see this. Now we are going to say actual the what is the device, then manage and connect. These are all layers, or these layers are integrated with each other. Okay. So now first we will see the devices. Devices means things that talk. Okay. So as we have discussed in the previous sessions that IoT devices can be categorized into two types, like one which have some form of intelligent inbuilt are there. Okay. Inbuilt, and those in which intelligence need to be enabled. So that means we are having uh, two kind of devices are there that we have to make the device intelligent, or some devices are already intelligent. Like here you can see that inherent intelligence are there, like devices like washing machine, a fridge, AC have some form of microcontroller logic. That logic is inbuilt and it can be used as a smart device. Here you can see that inherent intelligence means that intelligent is inbuilt. Like if you can consider the example of washing machines, ventilation and ACs are there. So these are the intelligent devices that a microcontroller is there, that logic is inbuilt in that devices. That's why that device act as a smart device. Okay. And some other devices are there like uh, animals, books, or for furniture techniques, like we have to use RFID. So for controlling or for managing this kind of things, we have to, or that IoT provides some functionalities or some identification techniques like RFID. That means we have to enable, or we have to make the devices intelligent. If we are going to consider the example of RFID tags, that means in the tag we are going to put that what we can say the serial numbers or some data into the tags. Okay, so that's why after inserting that data, or the tag holds some data, that after that putting the data, that device act as an intelligent device. That means we are going to enable, or we are going to make the device intelligence. So these are the two types of devices, that is inherent intelligence, or what we can say that inbuilt intelligence is there, or we are going to make the device intelligence. Okay, these are the two types of the devices. So like sensors are there, that sensors that are the devices that performs some input functions, or some, or sense some change in the surroundings. Sensors can recognize change in the heat, pressure or force. Okay. So here devices, if we are talking about the devices, sensor is the devices that perform some input functions. Based on the input, sensor performs some actions. Okay. So devices, sensors means the devices that responds to a physical stimulus and measures the physical stimulus quantity and converts it into a signal. Usually that signal is electrical signals. Okay. If we are going to consider the example in the next upcoming slides, we will see that several devices or several waves are there that we have to convert that signals into electrical signals. Okay. For that we are going to use the adapters. Okay. Then that sensors are also called as a detector. Okay, sensor is basically an electrical device. We have seen that sensors are basically an electrical device. It could be a machine-to-machine terminal, or RFID reader is there, SCADA meter is there. Okay, a sensor can be a very small, and itself can be a trackable device is there. Sensors are small electrical devices which can be tracked or monitored, or it can be used to track objects once that sensor is installed on that object. Okay, so sensors can be installed on objects as small as a card, or a smaller chip, or as a large in size if. Okay, so sensors generally draws energies from the battery power, but some alternate methods are there for that managing the devices. Like sensors individually are considered as a part of IoT. Okay, this is all about the sensors. So different kinds of sensors are there, like one thing is that device is sensors, and another one is actuators. That sensor performs input functions and your actuator performs the output functions. Okay, like we have seen that RFID tags are there that give some output to the device. Okay, different kinds of sensors are there. Here you can see the different kinds of sensors are there, like temperature sensor is there, thermal sensor is there, for pressure sensor is there. Okay, IR sensor is there, limit switch is there, gas sensor. Here you can see the different types of sensors are there. All the sensors are categorized into the based on their types. Okay, so we will see these types of sensors with the example. Here you can see for the position, for angle, for displacement, distance, speed, and acceleration. The sensors are position sensor, accelerometer, capacitive displacement sensors for the position, angle, and displacement, or the speed or acceleration. For this pressure, for pressure we are having the barometer, boost gauge, or pressure sensor is there. For acoustic sound and vibration, we are having geophone, hydrophone, flash sensor, or microphone. And for automotive or transportation, we are having crank sensor, vehicle speed sensor, then we are having wheel speed sensor, transmission fluid temperature sensor. Okay, or parking sensor. Different kinds of sensor is there, like engine coolant temperature is there, engine coolant temperature sensor, that is ECD sensor is there. Then for the environment, weather and moisture and humidity, we are having the leaf sensor, rain sensor, soil and soil moisture sensor. Okay, and for the optical light and imaging, for that we are having contact image sensor or infrared sensors are there. IR sensor is there. Okay, and for the flow or fluid, we are having flow sensor, gas meter, mass flow sensor. For navigations, we are having MHD sensor. Okay, so these are these different types of sensors with their examples. Okay, then now we are going to see the next layer for the next part of that device connect and manage. We have seen the devices. Now we are going to see the connect. Connect means that is your pervasive network. So we know that communication forms the backbone of, or the communication is the backbone of the IoT based systems, that we have to communicate with the device to device, or we have to transfer the data from device to device. So there are several communication technologies are there. That communication technologies are divided into two major parts. One is your wired communication, or another one is your wireless communication. So both the wired and wireless communication have categories, like broadband or narrowband communication, short range or long range communication also is there. So the connectivity domain allows wired as well as wireless broadband network. In the first architecture, that is three-layer architecture, we have seen the communication network. In that we have seen the broadband network is there. Okay, that is your connectivity domain, that may be your wired or wireless broadband network. So the communication network can use copper wires, optical fiber cables, and air as a transmission medium to achieve the connectivity. Remember that communication network can use copper wires, optical fiber cables, or air as your transmission medium. Okay, so this data transfer is done in the form of small packets. and are routed independently across the network. For that, we are using that IPv4 is used for to provide that addressing mode for the devices in the IoT system. Okay, and we are having the IPv6 as well for the addressing support. And the wireless communication is very important, as the if we are going to consider the four pillars of IoT system, or we are going to consider that four pillars based on the wireless communication, that is your machine to machine, WSN, RFID. Okay, these are that pillars are based on the wireless communication. And that if you are going to consider that SCADA based, it is a short range wired field bus is there. Okay, so that pervasive network consists of these two technologies, that is wired and wireless network. Okay, so if we are talking about the wired communication, that wired communication for this IoT system are categorized into two types. The types are your short range field bus network for SCADA application, and second one is your IP based networks for some M2M and SCADA application. These are the two types of wired communication. Okay, so first we will see the field bus. Okay, so wired communication for the field bus. So if we are talking about the field bus, it is the family of industrial computer network that allows us that allows a real-time distributed control of modes. Okay, so that name of that field bus, or it is the family of industrial computer network protocols, and that is used for the real-time distributed control of nodes. So that field bus is made up of two words, that is field and bus. So in this protocol, that standardization field refers to limited geographical or contextual area in the industry. Here you can see that that field means that field refers to geographical area, and bus refers to electrical medium. That medium carries the data. Okay, that is field bus. And if we are talking about the standardization, that field bus is standardized as IEC 61158. Here you can see that it is standardized as IEC 61158. Okay, so that standardized includes different 8 different protocols are there. That protocols, or we can say the types. Okay, there are different types are there, 8 types are there, from type 1 to type 8. So type 1 is your foundation field bus H1, and type 2 is your control net, type 3 is Profibus, then type 4 is PNet, type 5 is your foundation field bus, that is the high speed ethernet is there, and type 6 is your SwiftNet, type 7 is word FIP, and type 8 is your interbus. So uses most of these types uses the twisted pair cable or fiber as a physical communication media. Why? Because this is the wired communication. Okay, so most of these types uses twisted pair cable or fiber cables as a physical communication media with the network topologies like Profibus star means your foundation field. Okay, that is type 1 and the type 3. Okay, so most of the field bus data transfer is done using a small size packets in a serial way. Okay, that field bus also provides bidirectional communication. Okay, here you can see that it uses the bidirectional communication between the field instrumentation or field instruments and the human machine interface. And the foundation field bus protocol was developed on the basis of that OSI model. You know that the OSI layers are there, OSI model is there, but that it does not include all of these 7 layers. Okay, that OSI model. So that why that field bus mainly used for the SCADA based application. Okay, that SCADA based application uses the field bus. In the first session or in the second session, we have seen that SCADA application, and that we have seen that field bus is there. Okay, so that field bus mostly uses this twisted pair or optical fiber cables as a physical communication media, and it also uses bidirectional communication medium, and it mainly used for this SCADA based application. Okay, so here you can see the wired communication field bus communication for this SCADA based application. That application consists of the SCADA host with the high speed ethernet. That that SCADA based application having some nodes, that SCADA node is there, then internet is there. Okay, the internet may be your LAN network. Okay, and with the H1 field bus. Then it's having the PLCs. PLCs or RTUs. PLCs means your programmable logic controllers, and RTU means your remote terminal units. Okay, so this is the general field bus communication with the SCADA application. Okay, then there are some examples are there for the field bus, like automatic meter reading is there. For that it uses the mode bus, and then for building home automation it uses the backnet. Okay, then it uses another example is your power system automation. For that it uses the Profibus. Profibus is your type 3. And another application is your process automation. For that it uses the Profibus, Profinet and Modbus. Okay, type 3 and your type 2 for that application. Okay, so this is all about your wired communication. And next type is your for the connect pervasive network, that is wireless communication. So we know that wireless communication for IoT based systems is categorized into two types, like short range networks like RFID, near field communication, WiMAX, wireless PAN, LAN, and MAN, etc. Okay, and another type is long range networks like cellular networks via GSM or CDMA. Okay, and wireless WAN and satellite communication as well. So these are the two types of wireless communication. Here you can see that two types of like short range and long range. Then here, so that wireless network, uh, here you can see that wireless network or that type of that network that establishes connection without the cables. That is your wireless network. Any type of network with the or without wire connection, that is your wireless network. So wireless communication uses electromagnetic waves. It consists of or it is used Wireless communication uses electromagnetic waves that travel through the air. Okay, see the transmission media is air now in case of wireless network. So see the example like a radio, that is we are having the electromagnetic wave for that. If we are going to consider the examples like WSN and the RFID, it uses short range mesh network as its central communication technique. Is that WSN and RFID uses short range networks, and M2M, machine to machine uses long range cellular network for the communication. If you are going to consider the see the examples like wireless communication, what is wireless communication? Yeah, see the example like when we listen a radio in a moving car, we are actually receiving radio waves. Okay, so which is one type of electromagnetic wave. That means we are receiving the electromagnetic wave, and where that some device we are having that converts that waves into your electrical signals. Okay, so that wireless communication can be achieved through radio frequency, microwave, or infrared. Okay, so radio spectrum uses electromagnetic radio frequencies lower than 300 gigahertz. So various range of radio spectrum is used for different applications. Okay, so now in the next slides we will see the short range and long range for the wireless network. Okay, so now here you can see that where the signals we are receiving, that is your analog signal. That electromagnetic waves are your analog signals, whereas we know that the computer is understanding the digital information only, or digital information in the form of digital. Okay, so that wireless system transform that analog signals into digital. Here you can see that we are receiving the analog signals and we are having the adapter. That adapter is used for to convert that analog signals into that digital. Okay, then we know that the categories of wireless communication like short range, medium range, and wide. Okay, that is very long. So short range consists of the networks media like Bluetooth, infrared, and Zigbee. And for the medium range, we are having Wi-Fi. And for the wide area network, we are having cellular communication and we are having satellite communication. So now see the range of short and long range of wireless networks. Like we are having the wireless personal area network. See the range of that, like 10 meter. And for the wireless LAN, that is wireless local area network, we are having the 100-meter as a range. And for the wireless man, that is metro area network, we are, or metropolitan area network, we are having the range as a, like minimum 5 kilometers, or distinct range is there. Okay. And for the wireless wired area network or wide area network, we are having range as like near about 40 kilometers, like. Okay, so that means we are using CDMA, or cellular network, or we can say that uh, what is that network we have seen, that is cellular or the satellite communication we are using. Okay, that in that case, that range is difference ranges differ for this your according to your geographical area. Okay, so this is all about the short and long range of that wireless network. Okay, so there are different standards are there, different standards, or we can say the different mechanisms are there for the wireless communication. So the standard of wireless network is like RFID and NFC. These are the part of your wireless personal area network. That wireless personal area network having the RFID and NFC cards are there. And for the uh, PAN network, that is IPv6 low power wireless personal area network. And another one standard is your body sensor network, then home IR networking, then home RF wireless RF home networking is there. Okay, so these are the standards of your wireless networks. Then next one is your the wireless communication mechanisms. So different wireless communication mechanisms are there. Okay, so first one is your ad hoc sensor network. Then like here in this slide you can see that OFDM is there. OFDM is there. That frequency division multiplexing. There is orthogonal frequency division multiplexing is there. Or frequency division multiple access is there. Ad hoc sensor network is there. SDR, that is software defined ratio, is there. Then cognitive ratio is there, that is CR. Okay, so we will see one by one. That is, first we will see the ad hoc sensor network. So that this network provides connectivity to two or more mobile devices for a temporary basis without any infrastructure. Okay, so that ad hoc network requires very less administration, low cost, and it can be deployed in a remote geographical areas. Okay, so this network can be integrated to a larger networks like internet. We can integrate this network into the larger network. That is your ad hoc sensor network. Then second one is your software defined ratio, SDR. It is a full-fledged software implementation for the hardware component like amplifier, filters, mixers, modulators, demodulators are there. So that SDR usually contains a personal computer and in analog to digital converters such as you can see that sound card and a front end to access the functionalities. Well, it provides a way to define parameters like radio frequency, modulation types, waveform properties, transmit frequencies. Okay, that is all about your software defined radio. That is your SDR. The third one is your cognitive radio. That is CR. It is an intelligent form of wireless communication where the transceiver, that is transmit and receiving, that is radio, to detect the spectrum or to detect the communication channel. It is in use and communicate this with the other nodes in the system. So when new communication is required, the occupied spectrum or the communication channel is not disturbed, and vacant channel is provided for the communication. Okay, that is that available channel is provided to the communication. So this is all about the communication mechanisms of the wireless network. Like there are several applications are there for the satellite communication, like weather forecasting, internet access, like global positioning system is there, communication with the ships, like then we are having TV and radio broadcasting is there. Okay, and that wireless communication medium includes the FDM or orthogonal frequency division multiplexing and orthogonal frequency division multiple access. Okay, so these are the two different variants of the same broadband wireless air interface. So see the what we can long form of the LTA, long term evolution. It is the standard for high speed wireless communication and it is used for mobile devices and data terminal in an OFDMA based technology standardized in third generation partnership project. This 3GPP, that is third generation partnership project. So that FDM, that frequency division multiplexing includes, see, the multiple access. That is FDM means your multiple access. Here you can see if we are having the Wi-Fi hotspot, that means if we are having the uh, multiplexing or we are having a single network and we are going to create the multiplexing of that network, that means we are creating the hotspot of that network, that single network is accessible by multiple personalities. Here you can see that we are having a single common channel and that this channel is accessible by the multiple personalities. Okay, that is multiple access. Then FDMA. See the example of FDMA, that is in the first generation only one person can transmit and receive the signal from that network. Okay. Then TDMA comes into picture, that is time division multiple access. That means every user getting the time slot for accessing that source. Okay, here you can see that several users are there, user 1, user 2, user 3 and user 4. Based on the time slot, we are going to give the access to the user. Here you can see that user 1 is having the different time slot and user 2 is having different time slot. Every user is having the different time slot and they can access their network or they can transmit or receive that data between the time slot only. Okay. See the examples of time slot TDMA. That is, we are having the frequencies like 200 kilohertz here. So we are having the different channels that could support only 8 users, like from 0 to 7. We can channels could support only 8 active users. So we have to transmit the data between these 8 users with that frequency. That means we are going to divide that frequency with that 8 users. Okay, in the second generation. In the second generation, we are using the GSM, GPRS, or the Edge. Okay, you know that what is GSM, GPRS, and Edge network. Okay, that is the second generation 2G network is there. So we are going to divide that frequency as per the requirement of that user. That means we are going to divide that frequency with the time slots, and we are going to give that access of that what we can say that network to that particular user with the time slot. And third one is your CDMA, that is code division multiple access. So every user in the CDMA get a unique code. Okay, so which is known as chipping sequence. So these codes are orthogonal, which means if these codes are multiplied together, it will give 0. Here you can see that example. If we are going to multiply these codes, we will get the 0. Okay. So based on these codes, we are going to give the access of that data to the users. Okay, that is your encoding technique. So this is the extra part with your syllabus. That means we are going to use the different kinds of access techniques are there, like time division multiple access, code division multiple access, and frequency division multiple access. Okay, so that CDMA includes the encoding and decoding techniques to send the data. Okay, and if we are talking about that FDM, orthogonal FDM techniques, here you can see that different data rates are there with the networks, with the generation that we have seen, the first generation, second generation, third generation. Okay, so different networks are different data rates are available with that networks. Okay, here you can see the different data rates are there. We are going to transmit the data based on this data rates. Okay, see the data rates, that what kind of key technology makes LTE so fast. It provides the highest data rate other than the first or second generation or third generation. It provides the higher data rate for the transmission. Okay, and that is 100 Mbps plus. That is orthogonal frequency division multiplexing. So we will stop here. In the next session, we will continue with the FDM and the remaining part, that is manage. Manage means you create the business value. Okay, we will stop here. Okay, so anybody having any doubt? Participants, you can unmute yourself. If anybody is having any doubt, you can ask.
हॅलो
हॅलो.
सर ते आर्किटेक्चर याची स्लाइड दाखव ना.
कुठली?
आर्किटेक्चर ऑफ
लेयर्स ऑफ
आर्किटेक्चर ऑफ IoT ही फर्स्ट स्लाइड दाखवा ना एकदा.
3 layers architecture, no? This one.
Nine.
9.
ना सर. हो.
यामध्ये काय?
हो.
हॅलो, काय विचारायचंय?
काय नाही सर.
मग काय बघायचं होतं स्लाइड मध्ये? काय डाऊट आहे का? हे जे 3 लेयर्स आहेत ना, ह्या 3 लेयर्स यू कॅन सी दॅट DCM or DNA. Okay, based on the industries, these 3 layers are divided into these 9 layers as per industry. वेगवेगळ्या इंडस्ट्रीज ने या 3 ज्या लेयर्स आहेत, ओके, लाईक डिव्हाइस, कनेक्ट और मॅनेज, और डिव्हाइस, नेटवर्क अँड ऍप्लिकेशन, ह्या जे 3 लेयर्स आहेत ना, ऍप्लिकेशन, नेटवर्क अँड सेन्सर लेयर, या प्रत्येक इंडस्ट्रीने त्यांच्या ऍझम्पशन प्रमाणे किंवा त्यांच्या रिक्वायरमेंट प्रमाणे त्या 3 लेयर्स 9 लेयर्स मध्ये डिस्ट्रीब्यूट केलेले आहेत. ओके, समजतंय का अश्विनी? सर्वांना समजलंय का? Yes. Anybody having any doubt? You can ask free. Feel free to ask.